Hello there, my name's Keith Evans. I am the DSO Transition and Smart Grid Engineering Manager for Electricity Northwest. Electricity Northwest are the distribution network operator for the northwest of England, and we cover from the bottom of Manchester all the way up to Carlisle and the Scottish border. So today I'm going to be taking you through our transition to net zero and also our electric vehicle strategy. Next slide. So the role of electricity distribution has changed. So we take as a distribution network operator, we take the power from the national grid and we distribute it down into the local area. Now, historically, this was a centralized model, and with the way that technology is changing, it's becoming a lot more complicated and a lot more multi-directional, with not just generation flowing down the system, but we've also got generation, storage, demand-side response, electric vehicles, and consumer renewables, all going in and out of the electricity grid. And that means that it's becoming a lot more complicated to manage. So what we're doing as a network operator and all the other network operators around the UK is we're transitioning the way that we run the network so that it's less passive and a bit more active. So the benefits of this is that it will allow us to facilitate more low carbon technologies to connect to the network without needing to reinforce the network unnecessarily. And we're expecting that electricity demand is set to double by 2050 with all the new technology coming on board. So we need to make it so that all of our customers can have a cleaner, greener energy system ready for the kind of 21st century living. Next slide. So the industry term for this is distribution system operation. Now that's an industry term, but effectively it's the way that we change the way that the network changes so that it's more active rather than just moving from A to B. It will enable us to have a long-term ability to meet the future demands for electricity, and it will help us reach the targets for the Northwest's net zero targets. Next slide. So DSO transition, it gives us a better customer experience that we can offer. So customers can be both producers and consumers, and this will lead to more choice and better service all around, as well as reducing the costs in the long term. We're also looking to standardise across the UK the way that the experience that customers are getting. The transition will also allow us to offer more efficiency savings using the network more economically. We're looking at whole system investment, so not just looking at our own network, but also working with other network operators. So there's independent network operators, there's the national grid, there's the gas and other energy vectors. And we're looking at how we can actually work together on all of these types of investments to actually make it so that the network is more efficient and that we're not reinforcing without the need to. Enabling low carbon economy, it's what we're all here for today. Actually allowing more of this technology to be able to connect onto our network, facilitating low carbon technologies, EVs, heat pumps, solar panels, wind, batteries, all of that, allowing it all onto the network. Opening up flexible markets. So we're actually giving the customers the ability to actually participate in energy trading and balancing, and to actually look at if their existing connections can be a bit more flexible, and the way that we offer connections to customers can be more flexible going forwards. You know, it doesn't just have to be the kind of 24/7, 365-day a year connections anymore. We can actually look at whether there's actually something a bit more suitable for the customer's needs. And all of this leads to increased productivity. So we'll be putting in new tools, new systems, trying to make it so that the process is easier, faster, more efficient, and that our colleagues all have the right amount of tools to actually increase their productivity and focus more on that customer experience. Next slide. So I'm also going to be talking about our electric vehicle strategy, which is a key part of our DSO strategy, and it's also part of the decarbonisation that we're looking at. So our electric vehicle strategy sets out our plans to lead and support our stakeholders on the journey to decarbonise the region's transport. Our role is to enable this journey by preparing the electricity network for the rapid uptake of electric vehicles and associated charging infrastructure needed to support this. To meet the rapidly changing needs of our customers, we're developing smarter, more affordable techniques to create a dynamic and interactive electricity network. And our customers and stakeholders have told us that we need to support them by offering a neutral and trusted source of impartial information as they take their first steps on the decarbonisation journey. Our stakeholders have also told us that it's important that we lead by example. So we're supporting our colleagues to embrace low carbon technologies and help them decarbonise their own individual means of transportation. The strategy sets out our ambition to facilitate the transition to EVs and make the Northwest a cleaner, greener place to live and work. In 2019, the UK became the first major economy to legally commit to the target of net zero carbon emissions by 2050. And here in the Northwest, local leaders have set some more challenging targets to achieve net zero by as early as 2030. Our customers will be connected to the networks which were not originally designed to accommodate these technologies. And the challenge for network operators as key players in the UK's transition to net zero is to continue to provide and plan for reliable and efficient network whilst accommodating increases in low carbon technologies such as EVs and keeping the costs as low as possible for our customers. So as you can see on screen, the way that the government's looking to do this, decarbonisation of transport is central to the commitment through the ban on sale of new petrol and diesel vans by 2030. And we're expecting around 1 million electric vehicles on the Northwest's roads by the end of the decade, with demand for electricity to increase by double by 2050. Next slide. So to give you some kind of timelines on things, some key milestones. So in 2019, a third of all the UK carbon emissions were linked to transportation. And in 2020, we actually saw that EVs accounted for 18% of all new car sales. In 2022, GMCA are looking to implement a clean air zone. And by 2035, we're expecting that all new cars and vans should be fully emission free at the tailpipe. By 2050, over 3 million electric vehicles connected to the regional network. Next slide. So, an electric vehicle. An electric vehicle is any vehicle that is powered by an electric motor. The term covers a range of transportation types, including cars, vans, trucks, trains, trams, boats, aircraft, bicycles, motorcycles. So it's not just kind of looking at an electric car or just road vehicles. There are a number of vehicle types, different types of EVs available, most of which can be categorized as pure electric or hybrids. And hybrids combine battery power with another fuel source, such as an internal combustion engine. Next slide. Benefits of electric vehicles. They don't produce harmful emissions, which is better for the environment and will help the UK reach net zero. They've got cheaper running costs. Charging an EV is currently around 60% cheaper than petrol and diesel, and maintenance costs are generally cheaper as well because there's less moving parts. There are incentives available through discounts on purchase prices, grants for installation of charge points, and preferential tax rates. They They improve air quality and noise quality within our towns and cities. And we can use renewable energy to recharge them. Wind, solar, hydro, which is all better for bringing us down to that net zero target. Next slide. So the role of Electricity Northwest is to maintain and upgrade the region's electricity network, plan for the future and support economic development and the transition to net zero, drive down our own emissions and help customers to do the same, support the government's net zero commitments, help our customers to make the switch to electric vehicles, and prepare the network for the connection of charge points. Next slide. So our electric vehicle strategy sets out the actions which we'll take to lead and support customers and our wider stakeholders on the journey to decarbonise the region's transport. It's made up of 5 key principles, which are making it simple, listening to our customers, working smart, leading by example, and playing our part in the national strategy. Next slide. So, making it simple. We already offer self-service tools which will allow our customers to check their location on our low voltage network and connect their EV charge point or request a supply increase. Currently, this service is aimed mainly at domestic and small commercial customers. We're also looking at our connections processes. So our fit and inform policy ensures that the majority of domestic and small commercial EV charge points can be connected to the network without the need for a connections application. We have a wealth of knowledge that we can share with our customers, including experience of installing EV charge points at our own sites. And we have a number of company experts and external contacts available to answer customers' questions on almost any subject relating to electric transport. In most cases, new electric vehicle charge points can be installed without the need to reinforce the surrounding network. But occasionally we need to carry out additional work to maintain the quality of supply. For the vast majority of our customers, this work will be carried out free of charge. There may, however, be charges for sites requiring significant levels of new capacity or for new customers. And if we determine that an installation needs to be upgraded, we'll look at options to reinforce the network using flexible solutions where these are economical and practical. As with any new technology deployed on the electricity network, it's important that our colleagues are provided with appropriate training on electric vehicles and the connection of EV charge points so that they can properly support and advise customers. We will provide detailed training for our connections and operations teams, including safety implications associated with providing connections to EV charging infrastructure. Next slide, please. Listening to our customers. We will support and engage our customers and wider stakeholders to help them decarbonise their own transport. So local authorities. Local authorities often hold responsibility for defining local planning policies, determining the location of on-street charging infrastructure, defining local building standards, and providing public charging infrastructure on street and in council-owned car parks. They're also looking to decarbonise their own fleet operations. We work closely with all the local authorities in our region to ensure that the energy infrastructure is systematically incorporated into their planning considerations and that we're able to support their specific decarbonisation ambitions. Our close relationships help us to understand their requirements and what support they would like from us. Community energy groups refers to citizen-led projects or initiatives to reduce, manage, or purchase electricity. By engaging and supporting community energy groups in the early stages of project development and rollout, we can help ensure that the success of the project and promote greater uptake of low carbon technologies. And commercial and industrial stakeholders. Fleet operators and businesses currently account for over half of new vehicle sales within the UK. So they're a key market for us to support. And we work closely with businesses to help them decarbonise their own fleets and provide EV services. There are a number of actions that businesses can take, ranging from individual small-scale changes to major national infrastructure projects designed to decarbonise transport. Our website offers a good source of up-to-date information on buying EVs, installing charge points, grants, tax benefits, and guidance on connecting charge points to the electricity network. We regularly attend conferences where we can share our in-depth knowledge. And we offer face-to-face support sessions for our customers to discuss their individual project needs and receive updates on our policies. We also publish our annual Distribution Future Electricity Scenarios document, which provides insights on a range of possible scenarios for the predicted uptake of electric vehicles and other technologies onto the network, including generation and heat pumps. Next slide. So we'll use innovation and investment to prepare our network for the rapid uptake of electric vehicles. So we have a range of innovation projects that we use. The innovation projects that we look at a holistic approach to the uptake of low carbon technologies, not just specifically focused on electric vehicles. And a good example of this is our with our smart street project, which optimizes the voltage on the electricity network to reduce the energy that home appliances actually utilize. So that actually delivers benefits to the customers, and they don't even know that it's happening. Vehicle to grid technology. We're working currently nationally at developing vehicle to grid technology. And vehicle to grid technology enables energy stored in an electric vehicle to be fed back into the electricity network. And it means that customers who have their own generation or solar panels can charge their electric vehicles using any excess energy produced from the generator and store the energy in their EV battery for later use. This also helps to reduce the level of peak demand on the electricity network. And in addition, customers can benefit from time of use tariffs by charging their vehicles when energy prices are cheap, and then discharging this energy to the grid when energy prices are lower. EVs could potentially be used as a power resource and contribute to balancing of the future power system. The increase in electricity demand and our ambition to use more renewable energy will lead to challenges in securing the capacity and balancing of the electricity network. Individual small charging units have limited impact alone, but when aggregated, these can provide a good source of commercially viable balancing services. And we're keen to work with aggregators to develop future flexible services contracts whereby we pay customers for the power they generate from their EVs to alleviate network constraints. We also offer flexible services to demand connections and to generation connections. So we've got an entire section of our website that's devoted to flexible services. I'd encourage you all to have a look at it because it's an excellent way of making a bit of extra revenue for your business through some of this adoption of low carbon technology, but also actually just managing your own demand as it is. We're investing in network automation tools to help us to operate the network more efficiently. Tools such as active network management allow us to utilize spare capacity in the network and create additional capacity via flexible services and flexible connections. And in the future, we'll be able to match demand created by the increases in EV charging with generation and demand response services. Smart charging allows EV charging not to overload the electricity network. And smart charging during off-peak periods when the electricity demand is low means that customers can benefit from cheaper electricity and unnecessary network reinforcement can be avoided. Charging can also be shifted to periods where there's plenty of clean, renewable energy available. And trials have demonstrated the benefits of preferential charging costs for customers and reduce strain on the distribution network. Next slide. So we're not just kind of sitting back and telling other people how to do this. We're also trying to lead by example. So our own low carbon technology policy in-house encourages our colleagues to transition to low carbon technology. This can be through a range of benefits in pool cars that they can drive. If they've got company cars, we're encouraging them to drive an electric vehicle instead. We're also encouraging people to just use more active transportation, and public transportation, like using the bikes, trains, walking. We provide on-site charging for at all of our sites, and we're also electrifying all of our fleet. It's more complicated with some of the bigger HGV type units and the vans, but certainly our cars, we're looking to replace all of our company cars by 2023. Next slide, please. And we're also playing our part in the national strategy. So we work with the rest of the electricity industry and transportation industry to inform national policy. And that's quite an important thing for us as a DNO, is that we do kind of, we're the voice, we can act as a voice of the Northwest's customers, and ensure that actually the policies, procedures, and working practices are right. I talked earlier about vehicle to grid, and one of the key things about that at the moment is that there's actually no standardization of vehicle to grid technology within the UK. So we're all working towards a standardization of that technology, so that in the future we can use that more to the benefit of our customers, and that we may actually be able to build that into a fit and inform type policy, which has already been established for things like embedded generation and storage devices. So they're the kinds of things that we're looking at from that perspective. Next slide, please. So we're now on to questions and answers. If anyone has any.
Hello Keith, it's Chris. I've been doing the slides for you. So we've got one in there from Eugene. And let me just sort of collect my thoughts reading it. So should domestic individual charges and business clusters be centrally controlled to manage local capacity, e.g. a street or a state? Do we need to upgrade smart meters to accommodate the supply and generation?
Centrally controlled? No, not necessarily. There are a lot of there's many approaches that are being looked at the moment with this. For businesses, central control works really well, and that is really good as a kind of offering, that if you're kind of putting charges within your premises, then actually being able to control all of them together and manage the supply actually can be quite beneficial, because it might mean that you need less supply overall. In terms of domestic installations, there are quite a lot of aggregators out there already who offer services. There's also suppliers who offer cheaper tariffs. And they will manage your supply for you, and you can choose what level of smart charging you want on that. You can either choose to go with a kind of, I trust my supplier to do everything for me approach, and you just plug your car in at the end of the day and trust that in the morning it will be charged to the amount that you've told it to be charged by. And a lot of those actually can offer quite beneficial charging rates. From the perspective of the smart meters, no, the current version of smart meters that are going in, they do have some capability of doing, actually enabling some smart charge capabilities, but actually at the moment a lot of the smart charging capabilities actually are outside of the smart meter program. The government are currently looking at whether the smart meter should be used for that, to give people like DNOs the capability to have some kind of emergency override if the network becomes distressed.
Right.
But at the moment, the capability is all within the smart charging devices.
Interesting. Just a couple that have been bounced about around the team generally, with regards to EV chargers. Some people have questions and sometimes confusion in and around the difference between what type of charger goes in at your home and what you would maybe find at a supermarket, or I've seen them in local pubs, or a rapid charger, etc. That or super rapid chargers, all the terms you hear. So what's the differences and the effects? Obviously, charging time seems fairly quite obvious, but in terms of the DNO, in terms of any sort of consumer knowledge, what's the difference between those chargers?
So the typical chargers that you'll see within domestic premises tend to either be around the kind of 3 to 4 kilowatt territories, or the kind of 7 kilowatt territory. 7 kilowatts is deemed to be a kind of rapid home charger. And for most people, that's the most you would ever need. You know, in terms of the charging speed is generally the main kind of point about this. And given how long your vehicle is actually stationary for, then often you find that a slower charger, so a kind of 3 to 4 kilowatt charger, is generally quite sufficient for a lot of people's needs. 7 kilowatts obviously gives you more capability in terms of if you need a bit more of a faster charge when you get home. If you're the kind of person that is depleting your battery on a regular basis, you know, if you're doing long mileage. And it might actually give you some kind of more capability in terms of smart charging and grid balancing services that you could offer in the future if you've got a bit of a kind of bigger connection. In terms of the effect on the network, every supply should be capable of a certain size of capability, and that's generally up to about 100 amps on our network. So that's the kind of 20 kilowatts territories. In terms of if you were to get kind of lots of them in the streets, then that will start having an impact on our network. But actually, as long as you don't exceed your supply capability, that shouldn't be an issue. That's just a network that's just our responsibility to come and upgrade the network or to find a solution to that problem. In terms of the retail perspective, obviously they're a lot faster, but you do pay a lot more as a premium for the fact that you're charging significantly faster. And actually, while I'm talking about that, it's actually quite an interesting point that different retail businesses will look at charging speeds differently. So I've heard quite good examples of some businesses who actually choose to install slower chargers because they want to encourage people to stay on site for longer. So that or the types of customers that they've got. So, you know, like kind of hotel guests or you know, large shopping outlets may actually, you know, they know that you're going to be there for quite a bit longer. So actually you may choose to kind of have a slower charger because you don't need the rapid capabilities. Whereas obviously motorway service stations or kind of anywhere where you want high throughput of vehicles, you'll obviously be going for the kind of ultra rapid types of capacities.
Oh, that's interesting. It's a good little insight that about the choice of chargers on sort of retail and hoteliers and whatnot. I think Darren, do you have a question? Yep. I can't see the chat, you see, so he's going to read one from the chat.
Keith, while Chris uploads the next presentation ready, I've got one more question in chat. Do you provide any maintenance proactive or preventive maintenance tracking warranty for charging stations?
No, not as Electricity Northwest DNO. No. We don't do any of that.
Okay. There is no more chat. There is no more questions. Keith, I'd like to thank you for your time.
Thank you very much.
Appreciated.